All right, guys, we've been doing a lot of talking about estimation, and we've been learning to estimate sums, differences, products, and quotients. And we have used different strategies for each one. And I just want to quick review what we have decided to do when we are finding actual answers to these operations that we use in math. So when we add two numbers together, we decided that when we want to check for reasonability, we can estimate to do that, and we can estimate by rounding, or we can estimate by using front-end estimation. When we talked about finding differences, we actually used the exact same strategies to estimate. And we found that both of them served us pretty well, although we did tend to like rounding a little bit better to get closer to our actual answer. And then when we talked about multiplication, we said, oh, you know what, we better just go with rounding, because when we multiply, things are getting big so quickly that if we were to use front-end estimation, then we might end up having our actual answer be way, way off from our estimated answer. So we decided that instead we are going to solely stick to rounding when we're multiplying. When we talked about division in class, we said, okay, actually we're going to ditch all of these and we're going to use something called compatible numbers instead. And compatible numbers has to do with using related math facts to determine if your actual answer is close to your estimated answer. So just as a review as to why we do that, let's pretend we have a problem like 51 divided by 6. If you were to use rounding or front end in this case, you would end up having a situation like this. Now, I don't know about you, but I don't know what 50 divided by 6 is, and that looks like it's going to take me a long time to figure out. And if you remember, the whole purpose of estimating is that you can do it really quickly in your head. So instead of rounding or using front-end estimation, I'm going to look for a compatible number that works nicely with 6. I'm going to find a math fact that is a multiple of 6 that gets really close to 51 so that I can kind of get an estimated answer here. So we can actually go two directions with this. In my brain, I could think of 51 as being 48 divided by 6, because I know that that nicely comes out to 8. Or I can go a little higher, and I could think about this as being 54 divided by 6, which I know is 9. And so this tells me that whatever 51 divided by 6 is, it's probably going to live between 8 and 9. And that actually makes sense to me, because if you did the division, you would find that the answer is 8 remainder 3, which does fall between 8 and 9. So these are compatible numbers. They work really well for estimating quotients, and that is what we are going to stick to. So let's look at a couple of examples, and you could do these along with me in your notebook, please. All right, we're going to only focus on estimating first. Let's first pretend we have to divide 69 divided by 9. Okay, so in your notebook, we can go two ways with this. You're thinking in your brain, you're thinking, okay, I definitely don't want to make this 70 divided by 9 because that's going to be a disaster. So instead, is there a multiple of 9 that's really close to 69 that I could use instead to get close? So I could think of this as 72 divided by 9 because I know 72 is compatible with 9. Or I could think of it as 63 divided by 9. And I've kind of gone both directions here. I've gone a little higher than 69 and a little lower. 72 divided by 9, of course, is 8. 63 divided by 9 is 7. And so my actual answer for 69 divided by 9 should live between 7 and 8. That makes sense because the answer is 7 remainder 6, of course. So I can be sure then that if my estimate is 7 and my real answer comes out to be 7 remainder 3, that it's been reasonable and it worked out. Let's try another one. Let's say we have to divide 51 divided by 7. I want you to pause this video really quickly and tell me what you would be thinking in your brain for 51, and tell me what two numbers this quotient would lie between if we were estimating. Press pause, go ahead. All right, let's see how you did. I would have thought in my brain that this could be 56 divided by 7. And on the other side, I would say it could be 49 divided by 7. This is 8. This is 7. The answer lies between 7 and 8. That makes sense because the actual answer is actually 7 with a remainder of 2, which comes right between between both of these. Perfect. So that is reasonable. All right, let's try two that are a little bit harder. What if I have a problem like 74 divided by 3? Okay, so I'm going to estimate over here, and I'm going to find my actual over here. Okay, if I were estimating 74 divided by 3, now this, when I'm thinking about this, 74, I need a multiple of 3 that's close to 74, and it needs to be one that works nicely and easily for me. So I would say on the low side, I would think that this is close to 60, just because that's easy and workable with 3. And then on the high side, I would probably go with 90, because that is also easy and workable with 3. 90 divided by 3, of course, is 30. And 60 divided by 3, of course, is 20. So what this means is that my real answer better be between 20 and 30. So let me find my actual answer to 74 divided by 3 and see if I am right. Okay, so 74 divided by 3. Just like in class, I'm going to divide my place values. And I'm going to think in my head, okay, I've got 7 tens. Here they are. And I've got 4 ones. Okay, I've got to divide them up. So first, I'm going to take my tens. 7 tens divided into 3 groups. I could get 2 tens in each group, which means this would be in a group. And this would be in a group. And this would be in a group. So that's 3 groups of 2, which means that I have taken away 60. I still have this 10 right here, but I've taken 60 away. Remember that division is repeated subtraction, so I'm going to just keep subtracting until I have 0. So now 7 tens minus 6 tens means I have 1 10 left, which makes sense because here it is. And I still have those 4 ones that I haven't dealt with hanging out right here. So that 10, just like our cookies, cannot be divided up. So I'm going to need to break it into 10 ones. So now I have 14 ones, which is what this 14 represents. And that makes sense because I'm now in the ones place in my quotient, which is the next position I need to fill. 14 ones divided into 3 groups. I could get 4 in each group, which would mean that I would divide all these up and I'd still have these 2 little guys left, because that would mean that 12 of them got split up and there's still 2 ones left. So I would get 24 with a remainder of 2. And let me just check my estimate. Does 24 remainder 2 fall between 20 and 30? Yes, it does. So it is reasonable. If you need to rewatch that, go ahead. Try it in your notebook along with me to make sure that you're feeling pretty good. And then let's try one more, okay? In your notebook, I want you to do what we just did. I want you to try 87 divided by 3. I want you to put your estimate over here, and I want you to put your actual over here, and then compare to see if they're reasonable. Ready, go. All right, let's see how you did. If I were estimating, all right, 87 divided by 3, let's see what I would think. In my brain, I would think to myself, okay, what number is close to 87 and compatible with 3? I like 90 on the high side. And then I guess 60 on the low side would work with 3. So 90 divided by 3 is 30. 60 divided by 3 is 20. So my answer will live between 20 and 30. Let's see if I am correct. All right, so I'm going to do 87 divided by 3. Let me just draw my picture down here to help myself. 1, 2, 3, 4, 5, 6, 7, 8 tens, and 7 ones. Okay. So first, I'm going to divide up my tens. And so I have 8 tens split into 3 groups. I could get 2 in each group. So here's the first group, here's the second group, here's the third group. Okay. So I got 2 in each group, which means that I took 60 away. So there's 60 scribbled out. I still have 2 tens left, which makes sense because 8 minus 6 is 2. Can't forget that I also have those 7 ones left to divide up right there. So those 10s aren't going to work out for me. I'm going to have to trade them in for 20 more 1s, which means that all together I've got 27 1s here now, which is what is shown here. 27 1s divided into 3 groups. I could get exactly 9 in each group, and I will have divided all 27 up in that case with nothing left over. Does 29 come between 20 and 30, like my estimate asked or suggested? Yes, it does. It's reasonable. And you know what? It makes so much sense because, gosh, 87 is really close to 90, so I was already predicting my actual would be closer to 30 than it would be to 20. So, excellent job. Now that you've seen and heard this, you're going to need some practice. So move into a practice station, and good luck.